Welcome to video 2.3, where we're going to actually set up some lighting for the player's engines that will enable and disable based on the player's input. We will actually look at the particle effects in a separate video because particle effects could be kind of a long process looking at all the different settings. So let's begin. Now, one thing I did forget to mention in the previous video is I never renamed my background, and so it's still called plane. I am going to rename that to background. Alright, and so let's look at trying to create a light that's going to follow the player around so that we can enable and disable it as we need. So let's start by right-clicking the player inside the hierarchy and choosing Create Empty. Now you can additionally also, while the player is selected, go to Game Object and choose the menu option Create Empty Child, which will create an object that's a child object of this player ship. So I'm going to do that, and it creates this thing called Game Object. And so it's right now set to the same origin as the player is. But we want to move that, because this is going to be my light for my engines. So I do want to move it towards the back, but let's attach the light first so that we can see what this would look like. So let's first rename it off of Game Object and call this Engine Light. And push Enter. And so now it's called Engine Light. And then we want to add a component of, I believe light's under rendering. And then light, so a component rendering light. And that attaches a light here. And it is the type that we want, which is a point light, which I said is kind of like a torch. So it's like emanating from a single point and goes out to a relatively small amount. You can actually see the entire effective distance by zooming out. So the light's going to hit all of that. It will fall off as it gets further out. So let's move the light around. Let's kind of, while we have this engine light object selected, we're going to move it back a little bit and then move it up just a tiny bit so that it looks like it's truly in the engine. We may want it up a little bit higher like that, so a little bit outside of the ship so that it kind of lights up more parts of the ship. Maybe up here so we can kind of get a lighting on the entire back of it. So let's shrink this range a little bit. Let's drop it down to like 3. We can up the intensity a little bit to maybe like 2.5. But let's change it to a color. I'm envisioning my engines are going to be kind of a tealish color. And so I'm going to pick a bright teal for my lights. So I've made those lights to be teal. But if I'm looking down from the top down, I still don't really get a huge impact of those lights on the ship. So I might need to increase the Y value a little bit more to maybe here. And so that kind of looks like that would work as lights on an engine lighting up. So here's with it off, and when it turns on, the back of the ship lights up like that. And so that's what we're going to make flick off and on as we power the engines. So I think size 3 looks good. Oops, that's an indirect multiplier. We want this to be, the intensity wants to be 2.5. So kind of bright. But again, you can adjust the settings to whatever you think is going to look the best for your vision of this game. And so since that's a child object, that light behind the player is going to follow the player everywhere the player goes. So I'm going to have this blue light coming out the back of the ship, but we want to turn it off and on with code. And so that's what we're going to try to do. Might clean these numbers up a little bit so they're less crazy looking decimals. So my Y value is 0.3 and my Z is negative 0.93. And that looks reasonably good. So we need to go back to looking at the code file for our ship to do this. So let's double click on player ship to begin editing the code here. And so not much has changed since we left off. You can see some of the effects of the physics movement and all that on here. But we do need to add a few more components to my variables. So underneath this rigid body for the ship, I'm going to add a light, and I'm going to call it engine light, because it's a component that I'm going to need to interact with. Then when we get to start, I'm going to need to bind the component to this variable called engine light. However, it's not going to work like this. And the reason we don't want to do it like this is while get component, I think it will search the children, we want to be more explicit in our search for this light. Like, if there was a light on player ship, it would actually find the components on the player ship. And I'm actually not 100% certain it would even find it here. And so let's actually switch it to a different way to do this. There's actually probably two main ways to approach this. So instead of using that style of code, let's demonstrate how to search for a specific game object. If I say game, capital G, capital O, game object, dot, capital F, find, I can do a string search for the name of the object I'm looking for. And so we can see that this is called engine light. And so I write that exactly as it appears as a string, so in quotes, and then dot get component light. And so what this would do is this would actually search the entire hierarchy for a copy of engine light. If two objects are named the same, I think it's going to find the one higher in the hierarchy first. But ideally, you should avoid that scenario completely. So this is problematic if you're going to allow two players to exist at the same time. And if both have the same name for the child component, you could end up in trouble. So another approach you could do is engine light equals get component in children. And so that will skip over the current object that this code resides in, because this code is bound to the player ship parent object. And so this is going to tell it to ignore the parent object that it's on and search in all of its children in order of the highest to lowest. So if I had multiple children, it'll start in the first one until it finds a light in those children, and then it will stop and return that singular light. And so that's another approach you can do to finding the engine light. So I'm going to choose the one where I'm going to get component in children. Then we'll try this one just to see what happens. So I'm going to manipulate my light. Well, I guess I need some variables here. Oh, no, I don't need it right now. So I'm going to manipulate my light inside of update. Because it's not a physics action, I don't want to handle it in fixed update. I want to handle it in update when I'm actually pushing the keys so that the light looks more responsive to my keyboard inputs. Since the update itself may not synchronize exactly to fixed update. That's actually also why we're using instance variables to store the input, because that way it persists over the frame call. So like if I were just to make this a local variable, there's no guarantee that this data would work with fixed update at all. So I store it as an instance variable. And I'm going to use that to determine if I have to turn the light on or not. So I'll say if input V is not equal to 0. I could get fancy if I really wanted to. I could make it like a red light for reverse and a blue light for forward, and I would just have to change this to being, greater than or less than accordingly. So basically, if I'm pushing this light, if I'm pushing the engine light, and if engine light dot enabled is false. So for example, the light's not turned on yet, then we would want to turn it on. So I guess we don't need this. Curly braces. Engine light dot enabled equals true. So this will, if the light is off, turn it on. And then we can do an else case here, else, and this is if we're not pushing forward. So if we're not pushing either of those, then we can do the same thing. If engine light dot enabled equals true, then we will turn it off. We will say engine light dot enabled equals false. The reason why I have this if statement check is you don't want to every single frame be telling the engine light to turn itself off or turn itself on, because it might actually send too many commands to the component and it could cause some weird behavior. I've had issues with it in the past where it might take a few frames for the light to actually turn on by doing it, by not having the if statement. And then plus, that's just wasting CPU time. I shouldn't be issuing a command to it if it doesn't need to change. So that's actually what we're doing. We're checking to see if it's on and then turning it off, checking to see if it's off, then turning it on. That is a slightly more efficient way to handle this. So let's test this and see if it works. So we can hit save. And then we should have correctly bound this. If we fail to find the light component, we end up getting a null pointer exception. And were that to happen, Unity will continue functioning, but the script will fail and any commands after the null pointer exception will not execute. And we will actually get a console red warning. And so I do want to cause that to happen just to see it. And let's default the light to being off. So when I select engine light, I can click this and turn off the engine light so that the default state is off. So we can hit play. And now when I push forward, we can see the lights turning on. And then when I stop, it turns off. And there might be a little bit of delay time. Like you can see that like if I tap the key, it might be hard on the video recording of 30 frames per second, but if I tap the key, it immediately turns off. But if I had held the key, it takes like a second or two to turn off. And that actually has to do with the input decay. Maybe we can catch it if we put some debug statements in here. Where we can actually put this command here. And maybe we can watch it in the console. So when I tap the key, if you manage to freeze it, you might actually see that this is not exactly going to 1 instantly. And when I push it and hold it, it eventually reaches 1. And then when I release the key, it does take it like a fraction of a second to get back down to 0. And that's actually why it doesn't always look like the light turns off immediately. And that's because it's emulating a joystick's behavior of, like when you release the stick, it takes it a second to go back to the neutral position. And so Unity's kind of reflecting that with your keyboard presses. And so this is going to look a lot better if you do this on your screen. It's kind of hard to tell from the 30 frames a second of a video. But there's a few things you could probably manipulate this code with. But other than that, I'm not going to stress too much about that slight delay. Because to handle that, the code would have to get a little bit more complex. I mean, I guess, no, well, I'm going to try to do this. Now this might get it to turn off a little bit snappier. If the light is on and my input is less than 0.5, I think that might still cause it to look weird. I just don't think there's a clean way to handle this. So we'll just have to deal with the fact that it's going to take a second for it to look like it's going to turn off. I mean, that's not too bad. So this could be a good way to handle it, to make it look like it's turning off in a more snappy type. So this should wrap up our ability to make that light flick on and off. I guess let's see what happens if we pull this, and I'm pretty sure it should find the light because it will search the children for the light. So if I switch it to just doing get component, it should search in the children. If it doesn't, we'll see a null pointer exception popping up in the console. There we go. There is no, so it does not search the children. You can see it's very mad and those lights don't work. And then also we could do the find object version. And we can see that that one works without error as well. So we can either find it by exact name, which I don't really recommend, because if you're respawning the player, there might be some naming changes due to how Unity would change the name of a duplicate prefab. I think the safest call is to search for the light in children until there's a reason not to do that. And so that's my recommended way to search for the light. I'm going to leave this in the code because it's a valid option as well. And so that should control our lights. We've got correct engine lights effects. All right, and so that will work. So don't forget to save your work. And in the next video, we'll explore getting particle effects to come out of the engine when we're pushing forward. And that one gives it a nice visual flair to the game. So thank you for watching.